Hey guys, Jake here, coming at you with another math lesson today. Today what we're going to be going over is applying the chain rule when you have a composite function, which is basically the composition of three functions. The method I'm going to be going over is very scalable to a composite function that's made up of, like 4 or 5 or 6 or however many functions kind of all plugged into each other. But I just want to kind of talk about how the typical chain rule, which is dealing with a composite function that's just made up of 2 smaller functions, how that compares to doing it with 3 functions. I'll kind of touch on as well how that applies to doing it with more than 3 functions. It's the same kind of pattern, but basically I found this in a book called The Calculus Lifesaver by Adrian Banner. It's a great book, very helpful explanations of a lot of different calculus concepts. Definitely recommend checking it out. There's a link in the description so you can see that. But let's go ahead and jump into this derivative. So basically this is the function that we have, y equals x cubed plus 7x all raised up to the 8th power minus 5, and then all that raised up to the 4th power. So what we want to do is find the derivative of this function. That's our goal here. To do that, we can see that we need to use the chain rule because we have a composite function, right? We have basically this function plugged into, being raised up to the 8th power, and then we kind of have this minus 5 piece, and then all that being raised up to the 4th power. So we kind of have a couple different layers of a composite function. And in fact, like I said, this is going to be able to be broken down into kind of 3 layers. When you're dealing with finding a derivative like this using the chain rule, whether it's with 2 or 3 or however many pieces, you really want to kind of think about working your way from the innermost function out to the outermost function. So what I mean by that is, if we were to imagine plugging in some x value into this function and figure out what the result would be, what would order of operations tell you to do? What would you deal with first? And as you kind of worked your way on from there, what would you deal with second, third, and last? So if we were to plug in some x value, the first thing based on order of operations, especially based on how the parentheses are placed in this function, the first thing we would deal with is the stuff within the parentheses here, right? Just the x cubed plus 7x piece. First, we would plug in our x here, we would cube it, we would multiply it by 7, and then we would add those 2 things up. But based on where the parentheses are placed in this, x cubed plus 7x is the first thing that we would deal with. So as a result, we want to think of that as kind of our inner function. So what we're going to do is we're just going to say that that inner function is u. So we're just going to say u equals x cubed plus 7x, since that's our innermost function. Now what we want to do is think of this function y as a function of u instead of as a function of x. So all we have to do is essentially say y is now going to be exactly as it is here, except we're replacing all this with u. So doing that will give us u to the 8th power minus 5, all raised up to the 4th, right? To find that, all we had to do is make this substitution that we determined was our innermost function, and we just call that whole thing u. So now, this is kind of our second layer. Now you want to think about what your innermost function is at this point. If we plug in some value for u, based on where the parentheses are, what the order of operations tells us to do, the first thing we would do is raise it to the 8th power, and then we would subtract 5. Basically, what's in the parentheses here would be our innermost function, our innermost piece that we would have to deal with first. So as a result, all we have to do is say that this stuff inside the parentheses here is going to be our next substitution. So let's just say this is going to be v. So now we know v is u to the 8th minus 5. So now, same thing, we want to take this substitution, put it back in here, and now what we want to do is write y as a function of v. So if we replace all that's in the parentheses here with a v, we're just going to get y is v to the 4th power. So now we've gotten to our final layer. We essentially have y as a function of v, we have v as a function of u, and we have u as a function of x. So what the chain rule says is we're essentially going to multiply to figure out dy dx, which is the derivative of this original y with respect to x, so treating x as the variable of our function y. To find this derivative, it can be broken down into these 3 smaller pieces, which is the derivative of y, with respect to v, because after making all these substitutions, y is now a function of v, right? V is the variable within this function for y. So first we're going to find the derivative of y with respect to v, and then now that is kind of our bridge to go from y to v. Now we need a bridge to go from v to the next variable. So now we're going to find the derivative of v, and v is a function of u, right? U is our input of v. So we're going to find the derivative of v with respect to u. And now we need to multiply that with our bridge from u to x. So u is a function of x, right? X is our input that outputs u based on the substitution that we decided to make. So now we need to find the derivative of u with respect to x. So you could kind of think of this notation. These aren't exactly fractions, but if you kind of think of them for a second like fractions, imagine doing the multiplication of these three fractions. The du would cancel with the du here, right? This would cancel with this. And then the dv here would cancel with that, and all we would be left with was dy over dx, which is exactly what we have over here. So that's kind of the way I visually like to think about this, and kind of how you can remember this formula. If you're trying to get from finding the derivative of y with respect to x, you basically input all these pieces to kind of bridge you down one level further in. So basically the derivative of y with respect to v, and then from v you know that this next piece is going to be the derivative of v with respect to something. Since v is a function of u, it must be a u. And then to bridge from u to the next level, we need to look at the derivative of u with respect to something, and u is a function of x, so we can bridge u to x. So basically these are kind of three bridges to get you one level further into your function. So doing that, finding these three simpler derivatives would be all we need to find the derivative of y with respect to x. So let's do that now. First, we want to find the derivative of y with respect to v, so we're going to find the derivative of this function. Since v is our variable, finding the derivative of this function with respect to v just requires the power rule, so we can just bring the 4 down in front, lower the power by 1. So this is dy dv, and then we need to multiply that by the derivative of v with respect to u. So now this function, we're going to take the derivative with respect to u. So again, that's just power rule. We're just going to bring the 8 down in front, lower the power by 1. The derivative of 5 is 0, so that's just going to go away. And then we need to multiply that by the derivative of u with respect to x. So the derivative of this function u with respect to x, again, is just going to be the power rule. Bring the 3 down in front, lower the power by 1. Derivative of 7x is just 7. So now we have the derivative of y with respect to x is the product of these three kind of simpler functions. However, the issue is now that we have this in terms of v, u, and x, and we just wanted the derivative with respect to x. So now we have to take these functions and kind of substitute them back in to get it just in terms of x. So obviously this is already in terms of x, that's fine. So then the other piece we need to substitute is our u. So we can take u equals x cubed plus 7x and replace our u with that. And then the other piece is replacing v. So we know that v equals u to the 8th minus 5, but now that's in terms of u, so we also need to plug this in for u. So basically, by saying u equals x cubed plus 7x, that tells us that v actually equals u to the 8th, which is, since u is all this, it actually is just x cubed plus 7x, all raised up to the 8th. So now we have u in terms of x and v in terms of x. We could substitute this in for v, this in for u, and that should leave us with something that is what we want. So doing that gives us 4 times v, which is all this, so x cubed plus 7x up to the 8th minus 5, and all that is going to be cubed, so we're going to cube all that, and then we're going to multiply that by 8 times u to the 7th, and all this is u, so we're going to get 8 times x cubed plus 7x to the 7th, and then we're going to multiply that by 3x squared plus 7. So that's it for the derivative of this function. And like I said, we could apply this same kind of method to if we have chain rule of 4 or 5 or 100 different composite functions all being plugged into each other, we would basically just have an extra term for each kind of level of the composite function. So maybe as we work our way out, let's say we had one more level that we called Z, we would, instead of having our chain rule formula look like this, we might have to go from Y to V, V to U, U to Z, and then Z to X. So this would be like if we had 4 composite functions, a composite function made up of 4 pieces plugged into each other. We would basically just get an extra thing being multiplied and an extra substitution that we would have to make as we worked our way from inside to outside of our composite function. So like I said, this method is discussed in the Calculus Lifesaver by Adrian Banner. Go check that book out. It's got a ton of great reviews on Amazon. There's a link in the description so you can look at that. And I hope you found this video helpful. If you did, please give it a like, subscribe to the channel. Those are great ways to help support the channel so I can keep making more videos like this.